Welcome to The Explainer. Today, we're going to pull back the curtain on the hidden science that gives the products we use every day, our phones, our watches, even our cars, those beautiful, durable surfaces. We're talking about a world engineered at the atomic level.
So really think about it for a second. How do they get that perfect, vibrant, scratch-resistant finish on your phone? Well, the answer is this incredible process of precision engineering called sputtered thin film coatings. And it's wild. We're literally building these surfaces one single atom at a time. Okay, so to really get how this all works, we've got to start with the core technology itself. It's a pretty amazing process, and it's called sputtering. The best way to think about sputtering is kind of like atomic spree painting. Seriously, inside a special vacuum chamber, you're literally knocking individual atoms off a block of some source material and then carefully guiding them to land on a product. And boom, you've created a brand new, absolutely flawless surface. Now, it might sound super complex, but it really boils down to these three key steps. First, you create a plasma that energizes ions. Then, these supercharged ions act like a microscopic sandblaster, slamming into the target material. That impact knocks atoms loose, and those atoms fly across the chamber and coat the object's surface, building up that perfect, ultra-thin film. All right, so how do you go from just a general process to a very specific look and feel? Well, it's not random at all. Creating a certain color, texture, or hardness is kind of like following a super advanced recipe, where every single ingredient and setting has to be controlled with insane precision. And these are the three main knobs that scientists and engineers get to play with: the power level of the whole process, the kind of gas they're using inside the chamber, and the temperature of the actual object being coated. Each one of these directly changes the final look and feel. So let's take power, for example. When you crank up the power, you give the ejected atoms way more kinetic energy. So when they hit the surface, they pack together much more tightly. And as researchers like Xiaolin Zhang has pointed out, this leads to a denser structure. What's that mean for you? It directly translates to a harder, more durable surface that sticks better. Exactly what you want for a high-end product. Now for color. This is where the gas comes in. This is so cool. By pumping reactive gases like oxygen or nitrogen into the vacuum chamber, engineers can literally change the chemistry of the coating as it's being formed. And just like Jungwen Park's research shows, tweaking the flow of oxygen actually alters the film's phase structure, which is just a fancy way of saying how the atoms are arranged. And that is how you dial in the exact color and transparency you want. And, just like in baking, temperature is absolutely everything. The right amount of heat gives those atoms landing on the surface just enough energy to kind of wiggle around and settle into a really dense, organized, and smooth structure. This doesn't just improve the quality and transparency, it's crucial for getting that aesthetically perfect finish. Okay, so our recipe is all dialed in. Let's get to the main event, that moment when the atoms actually land and start forming the new surface. This is what we call the art of deposition. Now, to get a perfectly even coating across a whole object, you can't just toss it in the machine. Oh no. Engineers have to control everything: the exact position of the object, the shape and density of the plasma, even the magnetic fields that are guiding the ions. Every single one of these elements has to be perfect if you want a uniform finish. The thickness of the coating itself is also this really critical balancing act. For instance, research from Ivan Cusano on silver films shows that when the film is super, super thin, it's not even a solid surface yet. It's more like a collection of separate little islands with tiny gaps between them. And that dramatically changes things like its transparency and its electrical properties. We're really playing a game of nanometers here. Just how precise are we talking about? Well, for a material called indium tin oxide, or ITO, that's the transparent conductor in pretty much every touchscreen, films that are thinner than 130 nanometers show huge changes in how well they conduct electricity and how clear they are. To put that in perspective for you, that's about 700 times thinner than a single human hair. Wow. So the coating is on. We're good, right? Nope. The process isn't over yet. There's a final, absolutely crucial step called post-processing. And you can think of this as the final polish that turns a pretty good coating into a truly perfect one. A really common technique is called annealing. All this is basically baking the coated object at a high temperature. What that heat does is it allows the atoms in the film to kind of relax and rearrange themselves into a stronger, denser, more uniform structure. And the result is you get a big boost in both hardness and durability.
And believe it or not, it gets even more advanced than that. Beyond just a simple oven bake, scientists use some seriously high-tech tools, like super precise lasers and plasma beams, to refine the surface even further. This improves everything from how scratch-resistant it is to how smooth it feels to the touch. And this high-tech finishing touch? It is incredibly effective. Research from Nazneen and their team shows that a final blast of laser energy improves the coating's crystallinity, which really just means how orderly the atoms are arranged, and its hardness. The end result? A much smoother surface with way better aesthetic and electrical properties. So let's pull all this together. What does this whole deep dive into atomic engineering actually mean for the beautiful products we use and see every single day? Well, that final perfect aesthetic of that surface, it's a direct result of every single one of these stages working together in perfect harmony. It's like a symphony of physics and chemistry, from that initial recipe of power and gas, all the way to the deposition, the thickness, and that final polish. So the big takeaway here is this. The next time you pick up your phone or you admire the finish on a new appliance, just remember the incredible journey of science and atomic-level engineering it took to get there. It's not just a color, it's a masterpiece of material science, carefully constructed atom by atom. It's a pretty powerful idea to think about, right? When we can control the very building blocks of a surface, the possibilities for function, for feel, for beauty, they're practically limitless. Thanks for joining this explainer.